Students, in this video let us discuss about the PYQs of EAPCET related to Doppler effect from 2018 to 2024. Nearly 15 questions present in this video. I am going to explain in this video. Now the short trick which I used in this video I am going to explain first. First of all, you remember the formula F is equal to F naught V plus or minus V naught by V plus or minus Vs. In this F, we call it as apparent frequency. Apparent frequency means frequency heard by observer. Remember these points. F naught, actual frequency of sound source or source, which is releasing the sound or emitting the sound. Right? Now V is the velocity of sound. V naught, velocity of observer. Vs, velocity of source. This is velocity of sound which the source is releasing, and this is velocity of source. Right? Now here the formula will be written as V plus or minus V naught by V plus or minus Vs. You may say, madam, we may confuse and we may write Vs in a numerator and V naught in denominator. No need of having such kind of confusion. Why means just a small trick. Remember that in ABCD letters after O only we are getting S. So first what is coming? O. After O only in alphabetical series we will get S. So first O, no, in numerator you keep V naught. And in denominator next source is S is coming, no, you keep Vs. So F naught V plus or minus V naught by V plus or minus Vs. Right? And now here the next thing what I have to say is, so in mathematics what we know, if for example I am saying X is directly proportional to Y, I wrote. What does it means? So if X increases, Y increases. If X decreases, Y decreases. Directly proportional. Right? We will say this as directly proportional. Now next, in a same manner, if X is proportional to 1 by Y, what does this indicates? If Y increases, X decreases. If Y decreases, X increases. This concept I am using as a short trick. Okay, this concept. Okay, now when problems come, I will explain. For example, one I will explain. Now, here source is there. Here observer is present. Right? Now source is moving towards the observer and let us assume he is at rest. Let us assume he is at rest. Now what is our formula? F naught V plus or minus V naught by V plus or minus Vs. Our formula. Right? Now here observer at rest means V naught is equal to 0. No? You remove V naught from the formula. Just write V. Divided by V plus or minus S. Whether you have to keep plus or minus. Now this is the apparent frequency listened by the observer. Right? Now source is coming towards the observer means what? The distance between or wavelength between the source and observer is decreasing. Wavelength is decreasing means what? Frequency is increasing. Wavelength is decreasing means frequency is increasing. Right? Now here for this frequency to increase, what we must keep? Minus Vs we have to place. For inversely proportional, no, 1 by it is. So for inversely proportional, if Y decreases, X increases. Now if we keep minus Vs, then F increases. Right? Now next, for example, the source is moving away from the stationary observer. Then in such a way, so observer as usual, he is at rest, I am assuming. So by V, it is moving away from the observer. Means the wavelength here is increasing. Wavelength increasing means frequency decreases. If we want the apparent frequency to decrease, compulsory here we have to keep plus Vs. V plus Vs. If this increases, this decreases. So in such a way, by using this trick, I am going to explain all the 15 problems related to the Doppler effect asked from 2018 to 2024. Right? Now, let us go to the first. Let us start with 2024, then 23. In such a way, I am going. So first, 9th May 2024, shift 1 question. A car traveling at a speed of 54 km per hour towards a wall sounds horn of frequency 400 Hz. The difference in the frequencies of two sounds, one received directly from the car and other reflected from the wall, noticed by a person standing between the car and wall is. He is saying to take the speed of sound in air as 335 meters per second. Okay. He is saying to take as 335 meters per second. Alright. Now see. First, for Doppler effect, remember that whatever he given in the problem, just you draw in a form of a picture, so that you will be easily understand that whether the source is approaching towards the observer or moving away from the observer. So depending upon that, you can formulate the formula by using the formula which I said to remember. So first what he is saying, car is traveling with 54 km per hour velocity towards a wall. This is the car and this is the wall. Wall means it is at rest. And here car is nothing but the source. Okay. And now it is releasing a sound of frequency. How much he said? 400 Hz. Right? Now, the difference in frequencies of two sounds. Here, what are two sounds? One, he is saying the sound which is received directly from the here. Where is the observer? He said a observer is standing between car and wall. Observer is between car and wall. He is in rest position. Right? He is in a rest position. Now, he is receiving two sounds. One sound coming directly from the car. Other sound goes towards the wall, reflects back. That we call echo. So, the other sound is the echo produced. He is listening two sounds. One directly from the car. Other the echo produced. Or the sound by the reflected sound wave from the wall. Right? Now, what he is asking? He is asking to find the difference in frequencies of two sounds. Right? Now, what he gave? Velocity of source. 54 km per hour. Here, source is nothing but car. So, 54 into kilo means 1000 and hour means 3600 seconds. So, if we simplify, we will get the velocity of source as 15 meters per second. Right? Now, next in the problem, he said to take speed of sound as 335 meters per second. Now, next, frequency of source, actual frequency of source, that is F0. What is F? Apparent frequency which is heard by the observer. Right? Now F naught is the actual frequency of the source. So that is 400 Hz. Now frequency of sound received by observer directly. Now this one. Car is coming towards the wall. In between observer is there. So car is coming towards the wall means wavelength between the car and wall is decreasing. Means apparent frequency is increasing. The sound heard by the observer is increasing. Car is coming towards the observer. So the sound directly heard from the car is increasing. So now F1 to increase. Here we have to keep in the formula minus Vs. What is our general formula? F naught V plus or minus V naught by V plus or minus Vs. No. Observer is at rest. Remove V naught. Now, in place of Vs, you will keep minus Vs. If you keep minus Vs here, this F1 increases because car is coming towards the observer. F1 increases. So formula is F naught V by V minus Vs. F naught 400, V 335 by 335 minus Vs, we got 15 meter per second. Alright. So now we got such an answer. Alright. Now next, frequency of sound heard by observer after reflected from a wall. The same formula. Why same formula? Means now this is the reflected wave, no? The echo produced, no? Okay, this is the sound here by the observer. Now this is coming from the car itself only, no? Car is moving towards the observer, no? Car is moving towards the observer means apparent frequency of sound is increasing, no? Okay, car is moving towards the observer and this is the echo coming towards the observer. So apparent frequency is increasing. So the same formula we will get F naught V by V minus Vs. Now both answers are same. So the difference in frequencies become F1 minus F2. So this minus this, nothing but 0. Hope you understood. So if you do the other 2 to 3 formulas, you will understand the short trick easily. You will be able to do other problems. Next one, a boy standing on a platform observes the frequency of train horn as it passes by. The change in frequency noticed as the train approaches and recites him with velocity of 108 km per hour is. He is saying to take the speed of sound in air as 330 meters per second. It is asked on 9th May 2024, shift 2. Right? What he said, a boy stood on the platform. First, a train is coming towards him. Train is coming towards him with 108 km per hour velocity, source velocity. And again, the train is going away from him or resides away from him with the same velocity 108 km per hour only. First, the train coming towards him and again passing by him or resides from him. సో ఇక్కడ వరకు తన దగ్గరకు వచ్చి తన దగ్గర నుండి ట్రైన్ దూరంగా వెళ్ళిపోతుంది. సో అటువంటప్పుడు తను ఏమడుగుతున్నాడు క్వశ్చన్ లో, ఒకటి ఇప్పుడు ట్రైన్ తన దగ్గరికి వచ్చేటప్పుడు ట్రైన్ తనకి దూరంగా వెళ్ళేటప్పుడు తను ఖచ్చితంగా సౌండ్ ఫ్రీక్వెన్సీలో డిఫరెన్స్ గమనిస్తాడు కదా, ఆ డిఫరెన్స్ తను కనుక్కోమని అడుగుతున్నాడు. సో ఇన్ ప్రాబ్లం వాట్ హీ సెడ్, one train is approaching him and again passing away from him. He compulsory notes the difference in frequency of sound. When train is approaching him, he finds that frequency of sound increases. When train is passing away from him, he finds frequency of sound is decreasing. Now the question he asked is to find the differences in these both frequencies. Okay, he's asking to find the difference in between these two frequencies. So in options he gave percentage. So we are finding the percentage change in frequencies. Right? So options I didn't wrote, but in options he gave in form of percentage. So here we have to find the percentage change in frequency observed by the observer. So first, the velocity of train while coming towards the observer and going away from the observer, same he gave 108 kilometer per hour. 1000 by 3600 means 5 by 18. So 108 into 5 by 18 we get 30 meters per second. Now next, speed of sound in air he said to take as 330 meters per second. Now Doppler effect formula F naught V plus or minus V naught by V plus or minus Vs. In every problem I am writing because to make you easy to understand. Now first, when train is going away from him, this situation. Okay. So F1 that is equal to F naught. So observer rest on the platform. No, he just stood on the platform. He is not moving. So remove V naught. V naught becomes 0. So V naught is equal to 0. Now divided by going away means wavelength is increasing. Wavelength is increasing means wavelength between the train and observer is increasing. Means frequency is decreasing. As the source go away from the observer, he notices the decrease in a frequency of sound of a train. Right? So now, in order to F to decrease, here we have to place plus Vs. So now substituting V330, 330 plus Vs, we got 30 meter per second. So we will get 0.9166 F naught, F1. Now next, this situation, when train is coming towards him, actually first I must say this. So by mistake it happened. So now it is coming towards him with same velocity 108 kilometer per second. So now what happens? Train is coming towards him means wavelength decreases between the train and observer. When wavelength decreases, when train is coming, he will hear the maximum frequency of sound released by the train. Means here F2 is increasing. For F2 increase, we have to write in denominator minus Vs. And V naught 0. So we removed V naught in the formula. So F naught 330 by 330 minus 30, you will get the answer as 1.1 F naught. Now percentage change in frequency observed, how we will write? F2 minus F1 by F2 into 100. Alright? So that is 1.1 F naught minus 0.9166 F naught by 1.1 F naught into 100. Now if you solve it, you will get 16.67 percentage. Alright. Now next one, asked here on 10th May 2024, shift 1. A source at rest emits sound waves of frequency 102 Hz. Right? Two observers are moving away from the source of sound in opposite directions, each with a speed of 10% of speed of sound. The ratio of frequencies of sound heard by observer. What he said? A source is at rest. Means here Vs is becoming 0. Two observers, observer 1, observer 2, moving away from the source, but in opposite direction. Let us think observer 1 is going in this direction, observer 2 is going in this direction. Right? Now, given frequency of a source, the actual frequency what he gave, source frequency 102 Hz. F naught is source frequency. F is frequency heard by observer. Remember that very well. Now, source is stationary, Vs 0. The velocity of sound he didn't give, so let us assume as V meters per second. Now, velocity of each observer, what he said? 10% of speed of sound. 10% of speed of sound. That is 10% of V. That is 10%, how we will write? 10 by 100 into V. That is equal to 0.1 V meters per second. Now, next what we have to write? From Doppler's effect, What is the formula? F is equal to F naught V plus or minus V naught by V plus or minus Vs. Now for observer 1, again here I am drawing source at rest. One observer, 2 moving this side, observer 1 moving this side, we are assuming. Okay, for observer 1, I am writing as FO1. F naught into observer is moving away from the source. Away from the source means wavelength increases. Wavelength increases means frequency of sound decreases. If we want less frequency, here you have to keep minus V naught. Directly proportional, no. Less frequency minus V naught by source velocity is 0, no. We are removing Vs by V. So substitute F naught V minus V naught. Now we calculated, no, 0.1 V by V. Now F naught is equal to F naught 1, we get 0.9 F naught. Okay. Now for observer 2 who is moving in positive x direction. Here also wavelength increases, frequency decreases. So in order for the frequency to decrease, we have to keep minus V naught by Vs, however 0. So V minus V naught by V. Substitute, you will get same 0.9 F naught. Now what he said? He said to find the ratios of these both frequencies. Okay. What he said in the problem? He said to find the ratio of frequencies of sound heard by the observers. So frequency of observer 1 by frequency of observer 2 is equal to 0.9 F naught by 0.9 F naught. That is equal to F by 1 by 1. That is equal to 1:1. 4. Now next, fourth question. An observer moves towards a stationary source of sound with speed 1/5 that of sound. The frequency of sound emitted by source is F. The apparent frequency recorded by observer. It is asked on 12th May 2023 shift 2. Right? Now, what he said? Observer moves to a stationary source. Source is at rest. So, Vs 0. But observer is moving. Okay? So, what he said? The speed of observer is 1/5 the speed of sound. Here he did give the speed of sound. No. Let us assume as V. So 1/5 the speed of sound. Speed of observer. Right. Now next, the frequency of sound emitted by source. He is saying to take as F. In the problem he gave F. Alright. Now Vs 0. F naught F. Velocity of source let us keep as 0. Velocity of sound V. Doppler effect formula. F apparent equal to F naught V plus or minus V naught by V plus or minus Vs, right? Vs क्या होगा? 0. Then here you have to place plus or minus. You think F apparent is equal to F naught. Why we will place plus? Because observer is moving towards source. Means wavelength decreases, frequency increases. Frequency increases means this is directly proportional. Now you have to place plus V naught. Directly proportional. If you keep plus here, frequency increases. If you keep minus here, frequency decreases. For directly. Right? For inversely, if you keep minus, F increases. If you keep plus, F decreases. Remember this trick. So, V plus V naught by V. What is V naught? V by 5. Now, solving this F and F naught, he is saying to take as F. 5V plus V. LCM is 5. No, that 5 goes into the denominator. 5V. So, 5V plus V, 6V by 5V. V cancels 6 by 5. F. 6 by 5 means 1.2. So, F apparent is 1.2 F. Hope you understood. Let us move for next question. An observer moves towards a stationary source of sound with a speed of 1/5 of a speed of sound. The apparent increase in the frequency heard by observer. He asked on 13th May, shift 1, 2023. Actually, both questions are same. But what is the difference means, here he asked to record the frequency observed by observer. That is apparent frequency. And here he asked to find the percentage increase in frequency. Here direct frequency, a percentage increase in frequency. Source as usual at rest. Observer moving towards the source. Vs 0. V naught, he said 1/5 of velocity of sound. Assume velocity of sound as V. So 1/5 into V. Right? What will be the formula? Observer is moving towards the source means apparent frequency of sound increases for him. So we will place plus V naught. So that F is increased. Now V plus V naught by V into F naught. Now he didn't said anything that to take F naught as F. So directly we are writing F naught. V plus 1/5 V by V. So you will get 6/5 F naught. But in this question he asked to find the percentage increase in frequency. అప్పుడు ఏం చేస్తారమ్మా, ఇది minus F naught, 6/5 F naught minus F naught by F naught రాస్తారు into 100. So you will get LCM 5, 6 F naught minus 5 F naught. This 5 I will write in denominator 5 F naught. So F naught by 5 F naught into 100%. 1/5 into 100%. 5 20s are 100. So answer is 20%. The percentage increase in frequency is 20%. Alright. Now next question which is asked on 14th May 2023, shift 1. A source and an observer move away from each other with the same velocity 10 meter per second with respect to ground. If observer finds frequency of sound coming from source as 1980, what is this actual frequency of source? F naught. Then actual, this is the frequency absorbed by observer. Observer finds the frequency of sound. So F apparent, this is 1980 hertz. Then actual frequency he is saying to find out. That is F naught he is saying to find out. So speed of sound in air he is saying to take as 340 meters per second. Here what he said, here, excuse me, here, sorry. Source and observer are moving away from each other with the same velocity. Vs 10 meter per second, 10 meter, V naught 10 meter per second. In problem he gave Vs is equal to V naught equal to 10 meter per second. Speed of sound he said to take as 340 meter per second. Now the source, the frequency founded by observer, frequency heard by observer, F is equal to 1980 hertz. From Doppler's effect, what is the formula? F naught V plus or minus V naught by V plus or minus Vs. Here both are moving. V naught and Vs both are moving. So what the formula becomes? F naught V. Observer is moving away from the sound source. Means what? He is moving away means frequency of sound decreases. So decreases means minus V naught. Directly proportional, no. So F also decreases. In case of source, it is also moving away from the observer, no? Okay. Away from the observer means the wavelength between both are increasing. Means frequency decreases. For frequency decreases, inversely proportional, now you have to collect plus Vs. If these factor increase only, frequency decrease. In both cases, frequency is decreasing. But what is the difference? Here this is in numerator. So if we keep V minus V naught only, frequency decreases. Directly proportional. Here if we keep plus Vs only, If V plus Vs increases, then frequency decreases, inversely proportional. So, apparent frequency, he gave 1980. He is asking to find F naught. Velocity of sound 340 minus V naught he gave as 10 by 340 plus 10. Now, if you simplify, you will get F naught as 2100 hertz. Right? Now, next question, which is asked on 14th May 2023, shift 2. A source emitting sound is tied to one end of a string of length 50 centimeter and rotated with angular speed 40 radian per second in the horizontal plane. The ratio of maximum and minimum frequencies of sound heard by observer standing at a distance of 10 meter from fixed end of string. He is saying to take speed of a sound as 340 meters per second. Now in problem, what he said, beta, source. One end of the source is connected to the string. String length 50 centimeter. Right? From the end of the string, at some 10 centimeter distance, observer is at rest. And he is just rotating in such a way, he is rotating the source which is producing the sound in a horizontal plane in such a way with angular velocity 40 radians per second. So length of string what he gave 50 centimeter. Okay. That is equal to 5 into 10 to the power of minus 2, that is 0.5 meters. Angular speed he gave as 40 radian per second. Speed of sound he said to take as 340 meters per second. Now, V equal to R omega, linear velocity. R is 0.5, omega 40, you will get 20 meter per second. This linear velocity gives us the velocity of a source. Alright? So, from Doppler's effect, V plus or minus V naught by V plus or minus Vs into F. Now, for maximum frequency, he is saying to find the ratio of maximum to minimum frequencies. First, for maximum frequency. Maximum frequency means, now if this is string, when the source of sound is rotating, okay, the rotating source comes nearer to the observer. Okay, it is some, from here, it is some 10 centimeter distance observer is there. So when rotating, when it comes up to here at some this 10 centimeter, observer is present. When the source comes nearer to him, he will find maximum frequency, no? Right? So he is at rest, so V naught 0, V by, for becoming maximum, here we have to write minus Vs. V minus Vs. Minimum frequency means here it came and again it is moving in such a way. Means moving away from this particular observer. Away means what happens? Frequency decreases. For decreasing, here we have to write plus Vs in denominator. So 1 divided by 2 you do F maximum by F minimum, F of V by V minus Vs, F of V by V plus Vs. F cancels, V cancels, you will get this goes into the numerator and this comes into the denominator, V plus Vs by V minus Vs. Right? Now substitute the values 340 plus 20 by 340 minus 20. Right? Everything he gave. We find it as 20 meters per second. So you will get answer as 9.8. Okay. Now next 8th question, which is asked on 9th September 2020. So in 22 and 21, he didn't ask any questions on Doppler's effect. He asked on standing waves open pipe. He didn't ask on Doppler effect. So directly going to 2020 shift 2. An engine sounding a whistle of frequency 2000 Hz is receding from stationary observer. Observer is at rest at 72 km per hour. What is the apparent frequency of observer? The velocity of sound he is saying to take as 340 meter per second. So, What he said, an engine sounding the whistle. This I assume as source engine. It is releasing some sound or whistling. And its actual frequency is 2000 hertz. That is F naught. Okay. F naught is 2000 hertz. Right. Now next, an engine is receding from the stationary observer. From here it is coming and moving away from the stationary observer. With how much velocity? Vs is equal to 72 km per hour. Convert into meter per second. 5 by 18 you do. You will get 20 meters per second. So this is 20 meters per second. Moving away from the observer is such a way coming and receding away from the observer. Right? Now next, from Doppler's effect, F is equal to F naught V plus or minus V naught by V plus or minus V naught. Vs. V naught you have to remove because observer is at rest. Now F naught Vy. Now it is moving away. Away means frequency decreases, no? So for a frequency here to decrease, here you have to keep plus Vs. So V plus Vs. If you write this, frequency decreases. Inversely proportional. So substitute all the values. F naught he gave 2000, velocity of sound 340. By 340 plus we find at 72 km per hour as 20 meter per second, converted into 20 meter per second. On doing the simplification, you will get approximately 1889 hertz, the apparent frequency heard by the observer. The apparent frequency heard by the observer is 1889 hertz. Right? Now next one, asked in 10th September 2020, shift 1. A bus moving with uniform speed. How much? Source is moving with 72 km per hour. If we convert into meter per second, we will get 20 meter per second. Now only we did in this problem, no. 20 meter per second. Velocity of a sound in air 340 meter per second. And he is saying that bus is moving towards the building. Bus is moving towards the building. And the bus is blowing a horn. The horn frequency is 1.7 kilohertz. The frequency produced by horn means actual frequency F naught. 1.7 kilohertz. Now as per now frequency of echo heard by bus driver. So now bus is producing a horn. It is moving towards the wall. Now the sound goes and incident on the building. And again it reflects back. That reflected wave of sound we call echo. Now he is asking to find the frequency of this echo heard by the bus driver. Driver will be in the bus. So he is asking to find the echo heard by this observer. That is driver who is in the bus. Here bus is source. Right? One thing you have to remember that here this is the vehicle bus. It is moving. It act as source. Driver is observer who is listening the echo reflected from the building. So he is observer. In the same vehicle acts as source and driver is in observer is in a source. In such a cases, bus is moving means observer is also moving, no? In such case, we will take Vs is equal to V naught is equal to equivalent to the bus velocity, or Vs is equal to V naught we will take. Right? Now substituting F is equal to F naught. First one, observer is also in motion. He is in bus, no? Bus driver, no? So he is in motion. He is coming towards the wall means the distance between the wall and him is decreasing. So frequency increases. For frequency increases, what we have to write? Plus V naught. The echo which it is coming towards him. So distance between him and echo is decreasing only, no? Means frequency increases, means you have to keep plus V naught by. Now bus is acting as source, no? Right? Frequency increases. This is also coming towards the echo. Now bus is moving in such a way, echo is coming in such a way. Means frequency increase. For frequency increase, in denominator you have to keep minus Vs. So formula becomes F naught V plus V naught by V minus Vs. So in this case, V naught equal to Vs we will take. That is equivalent to velocity of bus we are taking. So we are writing as Vb by Vb. So F naught he gave us 1.7. Now V 340, Vb 20 meter per second. So substituting these values you will get approximately 1.8 kilohertz. Right? Now next, asked in the same 2020, okay, two trucks heading in opposite direction, okay, opposite direction, each approaching each other with a speed of 0.1 u. Both trucks, truck 1, truck 2 approaching each other with a speed of 0.1 u. The speed of sound they are saying to take as u. The driver of first truck sounds his horn. Now he is having a horn and he sounds the horn. Okay. The frequency of this horn 495 hertz means actual frequency of horn F naught. Frequency of source F naught 495 hertz. Now let nu 1, nu 2 be the frequencies heard by the driver of second truck. Okay. Here nu 1 means when truck approaches near the first truck. That frequency. Nu 2 means from this second will go away from this truck. No. Now both trucks in such a way they are coming. Okay, they are coming. When this is second truck. When it is coming closer, the frequency is nu 1. And again these trucks in such a way, they are going away from each other. So that frequency nu 2. He is asking to find the difference between that both frequencies. Okay. As usual. First, let us write the, I didn't write here, forget it, V plus or minus V naught by V plus or minus V, yes. Right? Okay. Now, frequency heard by second truck driver only. Okay. Second truck driver, when he is approaching the first truck, I have to write it. So, when he approach first truck, okay, truck 1, truck 2, he is approaching towards the first truck. He is approaching towards the first truck. That frequency. Now what we will write? When he is approaching towards the first truck itself only producing the sound, no, by the horn of a frequency 495. Right? So what happens? Truck is coming towards him means the frequency of sound increases. Means you have to keep plus V2 by V minus. Now here also nu 1 is increasing means in denominator you have to keep minus V1. Right? Now V1 is coming towards him, V2 is coming towards this. So substitute the values Vu plus V2. Sorry, not nu. This is V. 0.1 U by U minus 0.1 U into 495. If you simplify, you will get a nu 1 as 605 hertz. Now from here, the truck is moving away. Truck 2 is residing or moving away from truck 1. Okay, now truck 1 is going in such a way, truck 2 is coming in such a way, moving away from truck 1. What happens? Frequency of sound decreases. Decreases means minus V2 you have to write in numerator, plus V1 you have to write in denominator. So formula becomes V minus V2 by V plus V1 into nu. Substitute the values. Okay, VU, V1 and V2 both say 0.1 U. F naught 495, you will get the answer as 405 hertz. He is asking to find the differences between these two frequencies now. So nu1 minus nu2 is equal to 605 minus 405. Answer will be 200 hertz. Okay. Now next. This is asked on 3rd May 2019 shift 1. Okay. So 11th question. A highway truck has two horns. In such a way, here I brought two horns A and B. So, when sounded together, driver records 50 beats in 10 seconds. With horn B blowing and truck moving towards the wall at a speed of 10 meters per second, the driver noticed beat frequency as 5 hertz. With the echo, when the frequency of A is decreased, the beat frequency with two horns sounded together increases. Calculate the frequency of horn A. He asked to find the speed of sound air is 330 meters per second. He is saying to take speed of sound in air. Now, let us understand the question. He gave a very lengthy question. So, nearly 2 steps we have to do. First step. First what he said, highway truck has two horns, A and B. Okay, we thought. Now, next, this truck sounded, at a time, he sounded these two horns. At a time when he sounded these two horns, he recorded the beat frequency as, beat frequency means let FA be the frequency of truck A, FB be the frequency of this second case, horn B. FA frequency of horn A, FB frequency of horn B. So beat frequency is FA minus FB. He observed as 50 by 10. That is 5 beats. 1 completed. The first sentence which he wrote, we completed. Next, what he is saying, now he is not horning A. He is horning only B. Okay, only B is making the sound. He horns only B. Right? He is horning the B or blowing the B and moving towards the wall. Wall will be at rest as usual. Moving towards the wall at a speed of 10 meters per second. ఏం చేస్తున్నాడు? ఫస్ట్ ఏం చేశాడు? ఏని బీని రెండిటిని బ్లో చేశాడు. బీట్ ఫ్రీక్వెన్సీ 5 బీట్స్ అని గమనించాడు. నెక్స్ట్ ఏం చేస్తున్నాడు? ఓన్లీ బీని మాత్రమే బ్లో చేస్తూ 10 మీటర్ పర్ సెకండ్ వెలాసిటీతో తను గోడ వైపు వెళ్తున్నాడు. రైట్? నో, ఇటువంటి సిచ్యువేషన్ లో హార్న్ బీని మాత్రమే బ్లో చేసేటప్పుడు తను బీట్ ఫ్రీక్వెన్సీ ఎంత నోటీస్ చేసిండు? 5 హెర్ట్జ్ విత్ ఎకో. ఎందుకంటే ఈ సౌండ్ ఇలా వెళ్ళి మళ్ళీ తనకి వెనక్కి వస్తుంది. రైట్? విత్ ఎకో. ఓకే. నౌ నెక్స్ట్ ఏమంటున్నాడు? వెన్ ద ఫ్రీక్వెన్సీ ఆఫ్ ఏ ఇస్ డిక్రీస్డ్, ద బీట్ ఫ్రీక్వెన్సీ విత్ 2 హార్న్స్ సౌండెడ్ టుగెదర్ ఇంక్రీజెస్. ఏ ఫ్రీక్వెన్సీ తక్కువ అయితే 2 హార్న్స్ ని ఒకటేసారి మనం మోగిస్తే బీట్ ఫ్రీక్వెన్సీ ఇంక్రీజ్ అవుతుంది అంటున్నాడు. ఆ ఏ ఫ్రీక్వెన్సీ తగ్గుతుంది అంటున్నాడు కదా, అది ఎంత అనేది క్యాల్కులేట్ చేయమని అంటున్నాడు. ఓకే. సో speed of sound 330 meters per second తీసుకోమన్నాడు. So here what is happening? In first case, at a time he blowed 2 horns. He observed beat frequency as 5 beats. In second case, what he is doing? Only he is horning B, blowing B and moving towards the wall. Okay. And he is hearing the sound of his truck in form of echo. Okay. So now, in such a situation, he observed beats as 5 hertz. Now he is saying that if A decreases, beat frequency when 2 horns sounds simultaneously increases. Now he is saying to calculate that frequency of A which decreases. Okay. And he is saying to take the frequency of sound as 330 meter per second. Okay. Here the first step, when horn B is blown, truck is moving towards the wall B, no? So F apparent is equal to, here what I will write, the frequency of B horn into V plus I will write, because now this is the sound going towards the wall and this is the echo coming from the wall. So truck is approaching the sound, I can see. So here what happens, apparent frequency increases. So here in numerator you have to keep plus V naught. Okay. The driver is in truck. Truck is moving means the driver inside the truck is also in motion. So V naught will be there. Now next is source velocity. It is coming towards this echo sound means apparent frequency is increasing, no? Means in numerator inversely proportional, no? You have to write V minus Vs. Now in such a situation, driver is in truck itself only, no? We will take V naught is equal to Vs. I am writing this as truck velocity. Now here, in both cases, he said the truck is moving with towards wall with 10 meter per second. Okay, in problem he gave 10 meter per second. Now, let us substitute. Okay, first let us find the frequency of horn B reflected from the wall echo. F echo equal to FB, V plus V truck by V minus V truck. V not equal to Vs. That I am taking as V truck. Both are same, no? So, beat frequency. How you will get beat frequency? If you minus FB from F echo. F echo minus FB. So, F echo is FB V plus V truck by V minus V truck minus FB. I took FB common. You will get V plus VT by V minus VT minus 1. Substitute the value V 330, VT 10 by 330 minus 10 minus 1 into FB. So, at this situation, what is the beat frequency absorbed by the driver? 5. He gave in the problem. 5 is equal to FB 340 by 320 minus 1. On simplifying, you will get a 5 equal to FB 20 by 320 or FB equal to 5 into 320 by 20. You will get 80 hertz. What is the frequency of horn B? 80 hertz. Now, next step what he said, if the frequency of A is here, if the frequency of A is decreased, the beat frequency with 2 horns sounded increases, he said. If A decrease, okay, now we have to find the frequency of A. Now, beat frequency with horns A and B is, in starting only we wrote 5 hertz, he gave. So, FB equal to FA minus FB. Now, 5 is equal to FA minus FB we founded as 80 hertz. Here, 2 possibilities are there, plus or minus we will write. One, FA may come 80 plus 5, 85 or 80 minus 5, 75. But in problem, he said that frequency is decreasing. Means FA is less than FB or FB greater than FA. FA must be less than FB, he said. In problem, FA less than means what is the value of FB? 80. Here 2 possibilities we say, no, 85 and 75. 85 will be greater than FB. So it is impossible because in problem he said FA must be less. Less means what you have to take? 75. 75 is less than 80 hertz. So FA is 75 hertz. Right? Now next 12th question. Asked on 3rd May 2019 shift 2. A musician on moving vehicle plays a tune at 880 hertz. Some tune he is playing on piano or something you think. And the frequency of that sound F naught 880 hertz. Right? Now next, when vehicle was approaching the listener, he received it as 888 heads. When vehicle is here, observer is at rest, vehicle is reaching the observer. And what he heard means F apparent, no. Heard by observer. F is equal to 888 heads. Now he is asking to find the velocity of source. He is saying to take the velocity of sound as 333 meter per second. Our general formula F naught V plus or minus V naught by V plus or minus Vs. V naught 0, observer is at rest. So the formula becomes F naught V by vehicle is approaching towards the observer means the sound frequency is increasing. Okay. So increasing means in numerator, it is in denominator, no, we will keep minus Vs. So if it is V minus Vs, F increases. So F naught V by V minus Vs. He is asking to find Vs. Let us simplify F by F naught equal to V by V minus Vs. Okay. He is asking to find Vs, no. V minus Vs is equal to V F naught by F. Now in terms of Vs, let us write, I am sending this to this side and this to this side. V minus V F naught by F equal to Vs. So Vs is equal to V, I am taking common 1 minus F naught by F. V he said to take as 333 meter per second. 1 minus F naught, the frequency of piano is 880 by frequency heard by observer, he said to take as 888. So 888 minus 880 by 888 into 333. You will get 8 by 888 into 333. So 8 311s are 888 and 313s are 333. So Vs is 3 meters per second. Hope you are understanding. Okay. Now next, he asked on 4th May 2019. Okay. Consider two tuning forks with a natural frequency, that is F naught. 250 hertz frequency of tuning forks. So one is moving away and another is moving towards stationary. Observer is here. V naught 0. One is moving towards, one is moving away from the observer. Okay. Now if observer hears beats of frequency as 5, let number of beats you assume as x, that is 5 beats. Beats, then speed of tuning fork he is asking. Velocity of source we have to find. Right? Tuning fork means here velocity of source only, no. Tuning fork is acting as source. One moving towards observer, other moving away from the observer. First tuning fork 1 moving towards observer. Towards means frequency increases. So in numerator we must have minus Vs. Right? So tuning fork 2 moving away from observer. Away means frequency decreases. So in numerator you have to write plus Vs. Observer is stationary, so we are removing V. Now substitute the value, no. Now beats heard by observer. Assume as x is equal to F1 minus F2. X is equal to F1 means F naught V by V minus Vs, F naught V by V plus Vs. F naught V you take common and take LCM as V minus Vs into V plus Vs. Here you will get V plus Vs minus of V minus Vs. Now F naught into V, A minus B into A plus B is A square minus B square. No, so V square minus Vs square. Now V strikes of Vs, 2 Vs we will get. Now V square minus Vs square you bring to this side, x V square minus Vs square equal to F naught V 2 Vs. But x is equal to 5, you substitute, bring 5 to this side. So you will get V minus Vs square is equal to 2 by 5 F naught V Vs. So Vs square, in terms of Vs square you write Vs square plus 2 by 5 F naught V Vs minus V equal to 0. Now substitute the values Vs square plus 2 by 5 into, now V he gave as 250 Vs. We have to find F naught he gave as, F naught 250. V he is saying to take as 350. Vs we have to find minus V 350 whole square. On simplification you will get Vs square plus 35,000 Vs minus 12 500 is equal to 0. Here to solve, we will use quadratic equation minus b plus or minus under root b square minus 4ac by 2a. Right? We will find the magnitude only. Minus 3500. Here b is my 3500. Now c is 122 1,22,500. And here a will be 1 only. A will be 1. Substituting these values, minus b 35,000 plus under root b square 35,000 whole square minus 4ac, no 4a 1c 1,22,500 divided by 2a means 21. Right? Now minus 35,000 plus this square is this much, you will get minus 4 into, if you do this value you will get, if you minus you will get this value, and under root of this value is 34,993 minus. So actually you will get the answer in minus 7 by 2, but we need only magnitude, so 7 by 2 meter per second, no need of minus. So answer will be velocity of the tuning forks is, which are acting as sources, 3.5 meter per second. Alright. Now next, the 14th question, which he asked in 2018 4th May. Okay. A source of sound whose frequency is 1000 hertz. Source of sound's frequency means nothing but f0, 1000. Now moving with velocity 33 meter per second. The waves reflected by fixed obstacle by receiver that moves together with the source. Receiver is moving along with the source. And one, it is going sound in such a way, again reflecting back from this fixed obstacle. The speed of sound wave 330 meter per second. Then frequency registered by receiver means apparent frequency is saying to find. Okay. So first, general formula I wrote, V plus or minus V0 by V plus or minus Vs into F. Case 1. Frequency of reflected sound. This reflected sound went up to the fixed obstacle and reflected me. So F1 I am writing. F0 V by V minus Vs as usual. Why V minus Vs? It is going. This is the source moving in such a way. This is the it is approaching the sound, no? Means frequency increase, no? So in numerator we have to write minus Vs. Right? So actual frequency he gave as 1000 hertz. Now V0 becomes, it is stationary. Obstacle is at rest. Let us take obstacle as observer. Okay, in this case, when it is moving towards the wall becomes the observer. Alright. Now next, actual frequency 1000 hertz. Now substituting the values, F1 equal to 1000, 330 by 330 minus 33, you will get some 1000 into 330 by 297. Now he is saying frequency absorbed by observer. Now in this case, light the sound wave reflected, no. Now in this second case, obstacle becomes source and receiver becomes observer. Right? In this case, obstacle becomes a source. From here it is reflecting and coming. So it acts as source and receiver acts as observer. So now here what happens? Vs is at rest. So Vs is equal to 0. In second case, he is the source, he is the observer. He is at rest. So Vs is 0. Now what remained? It is coming towards the receiver means wavelength decreases and frequency increases. So plus V0 we must keep. So F1 V plus V0 by V. Now here F0 what becomes? F0 means this frequency of reflected wave itself only. So in place of F0 I am placing F1, the reflected wave frequency. So 1000 into 330 by 297, 330 plus 33 by 330. If you simplify, you will get 1.2 kilohertz is your answer. And the last question in 2019, a whistle of frequency 660 hertz moves in a circle. Right? of radius 1 meter at angular speed of 10 radian per second. The highest frequency heard by listener at long distance. Remember this, long distance. At rest. Observer is at rest, V naught 0. With respect to the center of circle. Speed of sound 340 meters per second. What he said? A whistle of frequency 660 hertz, F naught, 660 hertz, moves in a circle at angular speed. So, a whistle, okay, moving in the circle with angular velocity 10 radian per second. Now, speed of sound 340, frequency of whistle F naught 660 hertz. Now, it is moving in circular path. Now, this is radius. So, R equal to 1 meter. Now, maximum frequency when he hear, now in such a way the sound reaches in both directions. Now, when the source moves, the whistle moves in such a way, means if we draw any tangent along this circular path, in such a way if it moves, listener hear the maximum velocity. Okay? Listener hears the maximum velocity. In this direction, minimum velocity. And another thing he said, this listener is very far from this circular path. So, theta becomes 0. Theta becomes 0. So, now the linear velocity, V equal to R omega. R 1 meter, omega 10. So, Vs is equal to 10 meter per second. As there is a long distance, theta becomes 0. The apparent frequency formula, F naught, V plus or minus V naught by V plus or minus Vs. V naught is at rest, remove him. So, V by, now here what happens when this comes nearer to the observer, towards the observer, what happens? Frequency of sound increases. So, F increases means in denominator you have to keep minus Vs. So, 660 F naught into 340 V, velocity of sound, by 340 minus 10. Here we calculated velocity of source. So, on simplification, we will get F is equal to 680 hertz. So, this is all about the Doppler's effect from 2018 to 2024 PYQs of EAPCet. Right? Here only one trick I used. In this formula, again I am saying, in case of observer, it is directly proportional to F. If apparent frequency increases, keep plus V naught. If it decreases, keep minus V naught. In case of source, inversely proportional, no, you find this term. So, in case of frequency increasing, you keep minus Vs. In case of frequency decreases, you keep plus Vs. Only this one trick I used and solved all the problems. So, thank you for watching my video. If you like my video, subscribe it and share it. Yours, Reshma Physics. Thank you.